for stream 6. Now, we did some stuff off stream. Well, I did some stuff off stream. And again, I'm talking to nobody, but either way, so I did some stuff off stream. I wrote, it was very ugly. I used GPT a lot. I stole stuff from Geeks for Geeks. But I wrote a B tree and a B tree test. So now we're going to be able to do indexes. The B tree is cool. It does what I need it to do. But I think when I go to properly rewrite this on stream, instead of rewriting this, I'm already going to bite the bullet and write a B plus tree. Mostly because this needs to get rewritten for deletions. And if you've ever written a B tree, you're going to know that writing a B tree to support inserts and stuff is easy, but writing a B tree to support deletions that then rebalances itself efficiently is very hard. Because it's not that hard to just re-index the whole B tree, but that's not, extremely efficient. So maybe what I'll do is I'll do it in steps. First I'll do a B plus tree, then I'm going to add deletions, and instead of creating clever rebalancing, I'll probably just re-index the whole thing, but I'll try to only do deletions in bulk operations, because then that way it's going to look a little bit better. So, yeah, we're going to start. I'm going to share this link super quickly to a couple people. I'm going to try to do this, and then we're going to start explaining what we're going to do. So I'll send this here. I'll send this here. You guys can't see this. This is off screen. And I'm going to send this to one more person. We're going to send this here. Actually, and let's go back here. We're going to do like that. Okay, cool. We're good to go. We've set everything up. So today, what I'm going to be focused on is I'd like to get my B tree. I'd like to get my B tree index working on insertions. So when I insert, I want to actually update my index. So we're going to try to create a little logic for hacky but inspiring. Yeah, we're going to try to create some logic for the insertions, probably for the create index logic, and then we're going to continue from there. So without further ado, we're actually going to start with probably an integration, because what I want to do here is I want to practice what is it going to be like if we insert a brand new record. I immediately want to know what block the record was put into. Then we're going to take that block ID and we're actually going to store it into our B tree. Now right now it's pretty simple because I think our blocks are pretty much the size of a record, but in the future we're going to have to modify our B tree, because right now I'm only storing the offset, where in reality I'm going to probably have to store some sort of map or an index of the offset, and then within that offset, what is the actual record ID. For now we're going to keep things chill because I have really small block sizes, so it's not going to get affected too much. So we're going to start. First things first, I'm going to say that this is actually an integration because we're going to be doing quite a few things at once. And we're going to create a new integration test, and let's call it, we're going to call this index, yeah, we're going to call this index test, or indexing test, not index test, that works. So we're going to have our index test. We're obviously going to steal from ourselves, because why would we not? Lovely, our friend is called an index test, sweet. For now, we're just going to call this test. It's not going to throw shit. We're not going to assert anything. And we're going to bring in our PP. If anybody's watching this from the talent days, you know how many PPs I left all over the code base. We're going to say meow. And sweet. And we're not using like a million of these things, so we don't really need any of this shit. Cool. And this is not a unit test. This is going to be an integration test. So first things first, let's just confirm that this is working. So we're going to run our index test, and we just want to run the test method. Also, if you're here from talent, you might see how funny it is that I'm writing tests. So, all right, we've There we go. Everything, we got our meow, our test passed. Amazing. We are good to go. So first things first is we're gonna create, so we have our data, very cool. Yeah, so we're gonna do something very similar. We're gonna have something identical to this, I would say. In our test, what we're gonna do is we're gonna create a, well, let's actually go see where we're doing this. So in our tests, we should have, in our service test, we should have a SQL test, and we never made an insertion test, which, unfortunate. Uh, no problem. Yes, I do probably the same shirt, but it's cool. It's cool, it's cool, it's cool. So let's actually go to, we're gonna go to app.java. Yeah, because we're mostly interested in this record here, and we're interested in inserting the record. There we go. So we want something like this. We have our table. So in fact, maybe I'm just going to go ahead, bite the bullet, and create a test. So we're going to say add test. We're going to say public void insert. Yeah, we're just going to say insert. We're going to pop this guy in here. Lovely. Cool. We should already have DB. What are you upset about? Public void insert, probably that it throws, yeah, it throws a declaration. No problem. And what we're going to do here is we're going to say underscore service test 0. And that's going to be our table. What are you upset about? No. What's going on here? Cool. What do you want? Add throws declaration. Nice. But then what's wrong with you? Duplicate method. Oh, okay, yeah, that's good. That's good. This is a good mistake. This is a good mistake. So what we're going to be focusing on is we're going to try to insert this record. So let's actually see what happens. And our insert method, let's check what's actually going on here. It doesn't, yeah, it does actually return true if we can successfully insert this record. Lovely. So in our SQL test, we are actually going to say Boolean response is going to equal this, and we're going to say assert true, and then we're going to put response because we do want to see if this is actually going to work. So very quickly, we're going to say we want to try doing our SQL test, and we want to see what happens on the insert method. Very cool. Sweet, 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 sweet. Our test fails because there is no schema. Sweet. That's actually a good mistake. Funny enough. So let's change our table name to just test2, I think. Test2, yeah, has a schema. We're going to try this again. Nice. And we should have another record there. Cool. So now we at least have a test here, and we're actually going to steal a lot of this logic because we're going to be putting it into our index test. So what we want to do here, you know what? We're actually going to delete test2.db. We're going to straight up delete this. Boom. And let's see what happens if we run SQL test again. Because we should have the schema, and it should just insert, yeah, nice. And we inserted one record. And so if we test our read, yeah, we're going to be focusing on this one. Cool. Cool, 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 cool. Java utils. Yeah, we do want an assert. But for now, we're not going to be doing anything. We're going to say SQL db equals new SQL, because that's what we're doing here. Correct. and we also want a hash map. So something I want to be doing on the insert, we do need to say that, yo, this guy's going to throw declaration. I think if we refresh this, yeah, test is going to be in here. We're going to move to bin, and let's try something here. This is probably a little dumb, but so am I. Serialized, and we're going to this point. This is the point at which it's going to get written. What I'm curious about is, do we use the block ID, or do we use I would say we use the block ID, to be honest. Block info, and then this should give us the block ID. If we go to suitable block, it returns the ID. Nice. Find suitable block. So blockinfo.id should exist. So now what we're going to try to do is we're going to say I want to print block info. So let's just see what happens here. We're going to do this a couple times. So we're going to yeah, whatever. I could have run the other one. So 0 and the ID is 0. When we run this again, block ID should be 1. Insertion point is 480 because that's the size of the block. We do this again because the size of our block is 480. That works. That's gonna, the record's probably like the offset within the block. So 960 times 2, perfect. Perfect, perfect, perfect. Okay. So I like what's happening here. So what we're going to do now is we're going to bring in our B tree. We're going to bring in our B tree, and we're actually going to, we're going to save our B tree index. So we have our data, we have our query, we have everything. So we're going to create a new folder called index. And this is where indexes are going to go. So let me try to think about this. And let me open our, not index test, we want to try our B tree test. So we don't need to do any of these. So yeah, we want to be able to load this B tree, and we don't care about printing anything. And we do want to print offsets. And we don't care, yeah, we don't care about this. So what we want to do is we want to load our B tree. We say B tree equals B tree, cool. And we need to be able to load this B tree from a JSON. I did not account for this when I built the B tree. Bit dumb. This is going to be a lot more work than I expected. So essentially, we do need, we could loop over everything. It's going to be like the most inefficient possible way to do this. Yeah, it's going to be grossly inefficient, but I think we have to do that. Yeah, so we're actually going to go back to btree index. And what we're going to do, so when we were inserting this, we're going to say event is apply. So we're actually going to say, nice, so in our btree test, we're going to say apply is at offset 0. Then right away, we're going to say event apply is at offset 1 as well. And by offset, I guess we're going to, by offset, we probably mean block ID. But we'll figure this out later. So we're gonna grab our B tree and we want to write it to a JSON. So our trees, this is our tree right now. And how do we collapse this tree into a, is it possible to write this tree? Okay, we might cheat here because this is going to be pretty curious how to do this. In Java, show in create create two methods that do the following. Commit, and commit, what is commit going to do? It is going to write the tree into a JSON file. Read will read a JSON file and build the tree from its contents. So let's see while this thinks. So I think we need two more methods within our tree. Commit to handle exceptions. We do. No, we already have this. We have our JSON, properly pronounced JSON. Okay, so let's see what this is doing. This is just saying make this a thing, boom, dump it out. Now read, I think, is actually going to be the harder method. Update tree. Let's try. First, we're going to write this commit method. We're going to bring our friend in. Nice. We're going to bring in the file writer. Nice. We're going to bring in this. Nice. And what we're going to do here is we're going to say that this goes into index/test2.json. So let's try in our B-tree test. We're going to create this, and then we're going to say tree.commit. So let's see what happens when we commit. B-tree test, and we want to run test. Let's go. Okay. Interesting. I do think tests were executed. B-tree test. Oh, and it's hashtag. Keep doing at for some reason. Nice. So if we go to index, we have our friend here. What happens? Type tree. Alright, so it's just storing, interesting. So it's storing everything like this. Update tree. We're going to go to our B-tree situation, and let's see what happens if we try to read our friend directly from, no, we don't want to put this into the B-tree test. What we're trying to do here is we actually want to put this into the B-tree. So we have a commit file. I'm going to put this here, and we're going to say persist to disk. And now what we're trying to do here is we'd like to, if we already have this on disk, which we should, we're going to create another class for maybe like an index manager or something along those lines. We have our file writer. We're going to grab our file reader. We do want, yes, we do want a type token. And what are you upset about? cool. So if we say read, update, read, and maybe what we want to do is we actually want to, so if we're here, maybe what we do is we say, we're going to say utils.pp, and we're going to print this.root. And we're going to bring in utils, but we should probably return. Or maybe we return this, and maybe read actually builds a brand new tree, I would assume. So let's go to btree test. We're going to remove most of this. Well, we won't remove. We'll just put this here. And then we'll say tree.read. Should be good enough. We don't want to commit anything. Nice. So let's see what happens if we run. Nothing fails, and we do have our tree. But what I would like to do here, what if we say, I'm a little bit confused about what happens here. So I'd like to create a new tree. This dot root, update tree, which updates the root. This recursively goes through and puts everything into here. And we do have a btree node. And what do we need to do to print our tree? When we try to print our tree boy, where are we at? Yeah. So let's go to our btree test. And when we try to print our tree, we need tree.root, and then we return true, right? And so what happens if we do this here? What is this? And can't I say this dot print tree? Sorry, this dot print tree, and then this dot root. Because we should have actually created a tree, if I'm not mistaken. So at our test, I anticipate this to fail, to be honest. Oh, sick. So I think what we should do is we say return this. Now this is screaming like, yo, what are you doing? This is a void. You can't return from a void. This method must return. I guess it's because we're not catching any sort of reflections. Maybe what we're gonna do here, how is this? Okay, I want this guy to return a new tree. And I guess maybe we just say return this, because it's going to be, maybe we return this no matter what. And then it's either an empty tree or it's not an empty tree. Let's go, baby! Boom. So it didn't fail, but now, if we go to our btree test, we're going to say tree.read. I'm going to say, oh, check this shit out. What if we say public static? And we're going to say tree equals new b tree. I guess I'll type 2, and we're going to say this is of type B tree, and then we're just going to say this. So we're going to say tree.root. Tree.root is tree.this. We're going to put a tree. What are you upset about? Cannot make a static. Well, actually, let's make both these bad boys static. Mwahahaha. Node.t is node. Then we're saying this, so maybe we'll also pass in the tree somehow, and we'll say tree.t. But can't we just pass in? Yeah, we're gonna say int t equals tree.t. Very ugly, but it's okay, because I'd rather just pass in the t. And we pass in t, int t, and we just say it's just equal to t. And how do we and we permeate this. Cool, and we return a tree. So if I'm not mistaken, I reckon this should work. So now we don't even need this. We just say btree dot read, and we say btree tree equals btree dot read. And then what we're gonna do here, we put this here, and we say utils.pp. We because of so much success. Holy shit. I believe that we might have done it. So what happens, so we're going to say from read, holy shit. This works great, thank you. So, you're welcome. We're best friends. I don't know if you've noticed, but we're very close. GPT and I. Now we're gonna insert a new apply at offset 10, and then we're gonna commit the tree. And see what happens here. So we run, everything runs, everything's doing what it's supposed to do. We built this, awesome. I forgot to print after doing that. And now check this out. What we're gonna do is, let's read this, and now that should be in our index. Yo, holy crap. We are doing it. Of course we cheated with these two methods. I'm a little bit surprised that this worked. I guess it's because we grab the JSON and immediately create. We'll see. I don't think we ended up modifying it a lot, though. I think we modified the fuck ton of it. Yeah, we did some crazy shit here. I don't know how this even works. We're gonna have to figure this out in the future. But in the meanwhile, that did definitely work. I don't like that the tree reader sort of is in here. I feel like that should be a bit different. They should probably move somewhere else. They should be maybe in like the index manager. We'll see what to do there. But now, in our SQL test, not in our SQL test, in our insert, what we're gonna do is we're gonna say, where's our index? Oh, index is here. Yeah, that's the schema. This is the index. So I think indexes should be per table, then per column. We'll figure that out afterwards. So when we do this, when we do the insert, we're gonna have something here that's gonna be like, yo, so we're gonna have something like private void update index. And so step one is we're actually going to move this method here. We're going to say private void read, or we're going to say, yeah, read index. And we're going to steal this from btree. And you know what? We're actually going to, instead of core, we're going to create a new file called indexmanager.java. Nice. And we're actually going to move all of this out to here. So our btree test, no, go to btree, yeah, we're going to steal this. We're going to go yoink. We're going to put this here, and then we're also going to do, yeah, we want to import a btree, we want to import .gason, t is t, visible t, yeah, we want file reader, yes, yes, yeah, change this to public, by the way, please and thank you. Node, we need to import, we're importing it from here actually. T is public, and probably maybe shouldn't be final or something, we'll see. And we want an exception class, lovely. Same thing, we want this guy to be public, and once again public. Kind of ugly, well, we'll see. It's not doing it. Oh, okay, done. So we have that. btree is now going to be complaining, and we can't read. So what we're going to do is we're going to say that this is the index manager, and that creates a btree. Let's try this again. Let's check that it works. Alright, it works. And to be honest, I think we're going to move the commit file out into the manager as well. We can move file writer. Yes. And we actually pass in a btree tree. And then we just say tree.root. Boom. Now, what we're going to do here is we have our tree, and I guess we're going to pass in the string index name. Nice. And we're going to interpolate this. We're going to say that index name goes here, and similarly here, we're going to say that read takes in a string that is called index name. Very cool. And then same situation again, we interpolate, and we're going to say index name. Cool. So we know that it's called test2. So in our B tree test, we're going to say read from file, and we're going to say index reader, and we pass in test2. That's going to be one of our tests. Then we're going to say write to file. That's going to be a different test. Then we're just going to say one of the tests is just going to be called, like, I don't know, test. It's just going to be the test. And that's our friend where we actually do create a B tree. So we say B tree equals new tree, B tree, sorry. Let's say I've typed this. We're going to insert like apply blah blah blah. No. Oh my god. What the fuck? There, 10, whatever. And then we're going to say tree.search, and we're going to search for key apply, and then we're going to say tree.print tree.root, I think, and then when we print our tree, we do it like this. So actually, we're going to steal all of this here. Tree.search. Okay, so we're gonna kill all of this. Array of integers, cool. We don't need this. Tree.search apply. Offsets for apply. We're also gonna insert like a click at offset. I don't know, 5 or 50, whatever. I don't give a shit. Click. And then we print our tree, and then we're not going to assert anything for now. Just chill. So we're going to read from file, and then when we write to file, we'll create an empty ass index. So we'll create a B tree, then we'll say B tree commit. So that's going to be this test, or we're actually going to say, ooh, interesting. Then we say tree manager, index manager dot commit, and we need to pass in a name, which is going to be test2, and we need to pass in this tree. And I think that should work. A commit takes in an index name and a tree. What are you upset about? Cannot make static references. Yeah, you fucking can. Oh yeah, was commit not static prior to that? Okay, yeah, that was a mistake. So this is where we commit to that. Then we're gonna say we're gonna copy this, and we're gonna say at test, and we're gonna have a public void update disk index. We do all of this. Here we're gonna say, because it's a test, we're not gonna pass shit in. We're gonna say string index name is just equal to test2. Very nice. Then we're gonna say, yeah, tree is we read the tree from read. Yeah, we print this right away. Then we're gonna insert a couple more nodes. Say 99, 98, and then we're gonna say index manager.commit index name and tree. Nice. And so that's our test here as well. So we've got a bunch of tests on the B tree. Very nice. I'm curious about this one. Say B tree test. Let's go. Oh man, compiled languages are just so nice to use. And where's click? Oh yeah, I guess we'll do another one where we'll say, I don't know, we'll say 9, and here we'll say 8, but then we'll say we want to add click, and we want to add view. Let's run this again. So that was it before. Now we have click and view here as well in alphabetical order, even though it wasn't. Sick. Alright, I believe this shit is working. Where were we before we got super distracted? So we'll close all of this. B tree, close this. We were at index manager, which we know works. And so now what we need to do is we're going to say update index. We're going to steal from B tree test. We're essentially going to say, what is my index here? Which is going to be update index. We're going to pass in a string, which is going to be our value. We're going to pass in a string, which is going to be our index name, and we're going to pass in an int, which is going to be our block ID. So we know we don't need index name. We do need B tree, and we need the tree manager. So we're going to delete this. Boom. Yes, go away. We're going to B tree test, no SQL test, no SQL.java, yeah. We are not going to print anything. We're going to tree.insert value, and then we're going to block ID. And then we're going to immediately commit this to the file. But, yeah, so we read from the index, and we immediately write to the index. What are you unhappy about? It's never used locally. We're about to use it locally, my friend. And we're going to say update index blockinfo.id, which is going to be the very last thing. Index name is going to come from index name. We're going to say this comes from index name. Index name. Index name for us is test2 because we've got an index. Porque, I guess we say get ID. And because we're still missing a parameter, but if we put an empty thing here, it's going to work. And so we know string object, and we're going to cast our friend, whoa, we're going to cast our friend as an integer. Nice. And so what we're doing here is we have our record, we have what we're looking at, and we know that we want this record to exist on, we have our record, which is a string to an object, and we want to do this on the value of, we want to do this on the value of, sorry, distracted. Because when we're doing our insert, let's go to our SQL test, it's the value of event. And so when we go in our actual SQL, in my record, before I serialize anything or do anything, it's going to be record dot get, and we want to put event, and we're going to cast our friend as a string because that shit outputs an object. Holy crap, let's find out if this works. We're going to run the insert once. There's no index, and if everything works correctly, we're going to say we want to run the SQL test insert. Let's go, baby! Please, please. Okay, I think that was a shit ton of warnings. Alright, uh, it was not, was it created? Did we create our index? Have we done it? Holy shit, I think we've done it. Holy shit, I think we've done it. So we've inserted an apply event with a price of 10 at, hopefully, index 0. Oh, Why is block ID? Oh, good. We're going to delete this. In the data, we delete the database, and I'm writing my own database from scratch for fun. And I am sharing only, wait, I could just, I guess, wait a minute, that's so dumb. I'm sharing only the screens I should be sharing because I don't want to get doxxed. Well, I mean, I'm cool with getting doxxed, but I'm not cool with doxing others. Okay, cool. Cool. What are we doing? Right. Did we delete the data? We did. So technically, we run this now. We're going to insert into the database. We're going to know that we put this apply event into index 0. We're going to see it all come to life. Lots of errors. It's okay. Did you do it? Index at offset 0. Data can't show you because it's serialized. We're going to do one more. We're going to put an apply event as well. This guy's going to have a price of 12. We insert this. Insert's going to work. Index is going to update. We come here. We now have apply at index 0 and at index 1. We're going to try inserting click. We don't care about the price of it. We run this again. Then we put an apply again with maybe a value of 0. So we check our friend. Ah, sad. It still did apply, but that's okay. That means we, or did I just not save it? We're gonna do click here again. Boom. We're doing that. We're reading. We're putting the value. The value should have been a click. Let's try this again. Maybe I somehow didn't save the file or something. SQL test. Oh shit, was I updating? No. It's cool, it's this one. We're gonna say click. The event is click this time. Let's go. Let's fucking go. Alright, please put this in my index. Put in block ID 2, which kind of seems weird, but boom. We have our click at block ID 3, so something broke. Something broke. Okay. But it's okay. It's cool. It's not looking too bad. So now, we are actually writing our shit to disk, which is crazy. Which is pretty fucking crazy. And also, what is this? No, I don't need B-tree test. So let's try something. We're gonna run our read method. Because now we should be able to read from disk. Sweet. Does our read not print anything? Are we dumb? Wait, is there even a read method? Oh yeah. I never implemented read. Oops. Big oops. We're gonna have an empty filter list. Cool. And we're gonna do a read. Now in our SQL test inside of read, empty filter list, yeah buddy, import this, import filter, import this, because eventually I'm going to put the query here, and then it's going to be all chill and shit. But for now, it's not all chill and shit. List of filters. So what do you not like? You got your table name. No, I think I imported the wrong filter. Where's filter for here? Dot filter. Yeah, see, I fucked that up. We want to import filter from my own friend. And now this guy shouldn't. This guy's even more mad at me now. Oh, okay, no, we're chilling. We're chilling. PP response. We're gonna print response, and we're gonna say read response. We're gonna read the response. Now we're gonna run a read test again. So we should have all of our records. So let's check. We have, yeah, so we always fuck up one of the blocks for some reason. And I guess we shouldn't have done that. Yeah, you know what? I know what we're doing here. We failed to insert one of the records. Actually, this seems really bad, because where the hell's my click event? Test2.db. Where is my clickety event? Am I somehow filtering something? Can't read block, but I only couldn't read one block. Price 0, price 12, price 10. Something that's strange to me is that it's not reading the click block. Let's try doing an insert on click again. We're going to insert click. Why did it do that like twice? Why did I see this? No, it didn't do it twice. Didn't do it twice. Okay, so we succeeded, and apparently we put it somewhere. We put it into block 3 or something. I don't know. Let's read. Okay, look at this. Way better. And now we have our click here as well. So let's delete our this friend. Let's delete our index. Something I immediately want to do is when we insert, we're only going to write if it succeeded. That's too much. That's too much. How do we know if it succeeds or not? It's going to be like boom, 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 boom. I guess, I mean, it should probably always, right? Okay, we've deleted everything. We're going to have a couple objects. We're going to have a click, then record 2, record 3, then we're going to do 5 records. Record 4 and record 5. We're going to do click, apply, click, view, apply. I don't care about the prices of the clicks. Doesn't really bother me or anything. Fuck the prices. And then here, we're going to copy this across the board. This is very ugly, but I don't feel like writing a proper test right now. We are just experimenting. So we're going to say record 2, response 2, record 3, response 3. Hopefully nobody who's considering employing me is watching this particular block happen. I am aware of smarter ways to run tests. Alright, everything's dead. We're gonna insert everything. Boom, 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 boom. does not match schema. Oh shit, did I delete the schema? No, I didn't. Int string int. What are you upset about? Did it insert anything? So, uh, schema should be fine. Index got created for click 0, and then it started failing. Aha! Well, actually, I don't know why that would act this way. I'm making my own problem much, much worse. Okay, yeah, I know. Oh, no, I don't know what's going on, actually. This is all very ugly. I should have done it correctly from the beginning. My bad. Lesson learned. We delete the index. We delete the database. We run our insert again. Let's go. Block ID 0, 1, 2, 3. So I have 5 events. Look, this should have been 0, 1, 2, 3, and for some reason record 5, I guess, didn't insert. Or block ID 0 twice somehow, which is no bueno. Uh, let's look at our index. So our index should now, it said click is at 0 and 2, and we failed to do apply, because that's one of the ones that failed. Click is at 0 and 2, is that correct? We did click at index 0 and click at index 2, apply at index 1 and at index 4. It's funny, the view event failed for some reason. No record of the view. Oh no, view at in. Holy shit, we did it. Alright, let's read. So we should have all of our records. 1, 2, 3, 4, and we never inserted the 5th. Price 0 ID 0. Price is, so it starts at click, which is correct, then goes to apply, then click, then, and it never did the last one. For some reason, it was unhappy about the last one, but it was able to put it into the records. Now, BRB, I'm gonna have to use the restroom. BRB. We're back. All right. It didn't insert the last record. File not found. No, but I should have just created it if it wasn't found. Block ID 0. Why did it not insert the last apply? Right? Because it did the view and then it shit the bed on the apply. So we're gonna do rec ID. Whoa, whoa, whoa. We're gonna redo all of this. We're gonna do 2. We're gonna do 3. We're gonna do 4. Nice. Now, in our friend, I think we should have. Okay, yeah. So the part that it tries to get the index, but then doesn't find it. It reads, and then here's, I think, our e.print stack, which is fine. We're gonna say utils.pp, and we're gonna say index file not found, just so the error is less intense. We're gonna bring in utils again. Once again, delete this. We're gonna create methods for this, but right now I just want to make it happen. Let's try again. Let's try insert. So 0, then put it in block 0 again. Something is very strange here. When we're saying block ID, when we say block ID, why are we saying block ID? Because we're saying that's where we're writing, or where am I screaming? Prepare new block. And actually, we're going to do this here. We're going to write, no, you know what? We're going to do this right when we write. We're going to say writing to block ID, and then we're going to say block info dot get, whoa, 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 dot get ID. Let's kill this again. Sorry for the repetition. It's annoying. Delete this index, yes. Delete the data, yes. Run our insert. Writing to block 4. So when we read, I think it's a read error then. I think it's just failing to read one of the blocks. And I think that block is, so let's go to our read, SQL test. Let's go to read. We go to db read. What we're going to do here, can't read block if add record is add record, which should be true. Block size. We're going to say for now int temp counter equals 0. Then we're going to say while, and then we're going to say temp counter plus plus, and then we're going to say reading utils.pp reading block at temp index, and then we're going to do plus temp counter. Alrighty, let's read again. Yeah, so it can't read the very last block. And por qué? Maybe because it says, let's actually print the E. It's lunchtime soon. EOF exception. In this logic, I am unable to get my last record from the file, and this is the error. How do I fix this? Please save me. I assume it's going to be like pad it or make the block size smaller by 1 or something. Beyond where the data actually exists. Try. It's true, we don't need a. Alright, let's try this little blocky boy here. So here's our try catch. Here's our try access random blah. Okay, so what did it change here? It is true that we only need read. I don't know why we have write permissions on a read class. We're gonna long file size datastream.length. Nothing changes there. Does anything change here? Datastream less than get file pointer identical. Nothing changes here. Long remaining, that's new. File size. Okay, interesting. Oh, interesting. Look at this. Our block size is fucking dynamic now. GPT, you are a smart little cookie. Read block fully, blah, 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 blah. Do the rest of this shit. Let's try. Pretty clever. Yeah, baby! Fuck yeah, we got our... Okay, so... And I guess let's do something interesting here. We're gonna say utils.pp block size, and then we're gonna do a plus here, and then we're gonna say remaining block size remaining, whatever, that's a typo, but I don't give a shit. Sorry, I'm getting very vulgar because I'm block. So block size is going to be what, 40, 480, 480. I guess there's some sort of padding I'm not accounting for. Alright, well, that works. So nowsies. If remaining is less than block size. Interesting. What did I even print here? No, I printed remaining, which is wrong. We're actually going to print block size. Yeah, let's do this again, because block size should be 480, 480, 480, 480. Yeah, and then our very last block, it's like, yo. So that's the file size minus the file pointer. And let's actually also print our pointer, because that's going to make a lot more sense. We're going to say pointer. No. We're going to say pointer, and we're going to point, because we're funny, to the pointer. So our pointer should be at 0. then 480, then 960, then blah blah blah. And then we do our file size is, I guess we'll also do this. File size, and we print the file size. I have to do all of this because I'm dumb. I can't just like mentally wrap my head around things. I have to like see it. File size. Boom. File size. Okay, so my file size, even though I said my file size, I actually never sort of made a file size, right? Okay, the file size is dictated. Okay, 264, and that's how big my records are. That's why that's going on. I get it. Let's get rid of the prints. Let's get rid of the read prints. So something I want to change now is but wait, when it says remaining 480, I see. I see. So we want to change this slightly somehow. What I want to do here, we're going to get rid of this. Can't read block. We're going to get rid of the counter. We're going to get rid of this. So I would like to actually have a little sort of method that says, please go to the data stream, go to a specific offset, and then read that block. And then stop. So we're going to try something. We're going to say, we're going to create a public method called read block. We're not going to have filters on this shit. We're going to keep everything identical. No filters. Hashtag no filter. Yo, so funny. Add record. Yeah, baby. Yeah. And then as soon as we get the record from this block, we just utils.pp record and we're done. So we're going to try something here. We're going to put here, we're going to say int, and we're going to say block ID. And for the seek, we're just going to say block ID, block size times block ID. And so check this shit out. We don't need this while. We're getting rid of it. And we're just saying seek, go to that block and print it. There's no more thing called records. There are no records. And this puts out a void. So let's try something. We're going to go to our SQL test. We're going to create a new test. Whoa. We're going to create a new test called public void read block. Nice. And it's going to do essentially this. Well, it's actually going to say db.readBlock and block 0. Now, oh my god, but what if it throws a warning? What if it throws a declaration? Oh no. But we say chill. We say chill out. It's all good. Now we're going to go down here and we're going to say read block. Okay. First of all, does my test make sense? Do I have any errors? No. There are test failures, test 1, error, test table name. That is dumb. My friends, it's good. We are experiencing good bugs. Holy shit, we got it. Okay, block ID 4, which should be, if I'm not mistaken, we could go look at our index. Block ID 4 should be an apply event. Oh my god, it works. This is crazy. How am I pulling this off? I mean, GPT obviously, but I'm still kind of impressing myself. So what this means now, what this fucking means is, so this read is kind of like a full table scan, and then this read is gonna be, yeah. So first things first, we're gonna go to read block, and here we're going to sort of say, yeah, we have our read block. That's like the specific block we want. Sorry, last thing I want to try is what happens if we read the very last block. Will this still work? If we do block 5, will I get my, what is it, apply event, I think? No. But wait, there is no, what block did I read from? I read from index 4, and there is no index 5. That was my last entry. And it failed on that one. Sweet! Because there is no index 5. Very nice. That's actually very good. So that's very good, very good. So what this means, what does this mean? That's how we deserialize shit. So here we're trying to read a specific block. And maybe instead of a specific block, because we want this, yeah, we're gonna have a loop inside of here. So first things first is we're gonna say index manager dot read, and then I guess here we say test2. Where else am I using index manager inside of here? Index name, yes, dot test2. And so this should give me a btree equals, I'm going to say tree.search, and why do I have a fucking file path? String key, that makes no sense. Yeah, it's dumb. We're searching for apply. And what is this going to give me? Tree.search gives me an array list of integers. Nice. So, and we're going to call this indices. And we're going to utils.pp utils.pp indexes. So let's try this quickly. So we know this, so 1 and 4. And so what we're actually going to do now is instead of having block ID here, which we're not going to have anymore, we're going to remove this. Don't need this. Yes, we need this. This is crazy. This is crazy. Read block. Cool. Block ID is going to be empty. Sadly, I haven't memorized how to do a for loop in Java yet. For each loop over this. It's kind of like for and then like element in indexes like that. Something. Let's see. For, right, close. It's going to be for integer. Oh shit, I had it. Ha 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 ha, shit, I did have it. Sweet. And then this guy's just going to be called block ID. And then, yeah, we put all of this side of here. Chill. We don't need to do any more conditionals here because, well, I mean, we will eventually because we're probably interested, or you know what, or, no, yeah, we'll see, because if I know what blocks I'm grabbing, grab those blocks, that's easy, but we might have additional indexes. So here we're going to have multiple indexes. We're going to ask multiple indexes, sort of do a leapfrog. Maybe one of the next things we'll code is leapfrog to determine that. And then there'll still be a list of filters which aren't part of all of this. Yeah, which aren't part of all of this. Yeah, we'll consolidate the code afterwards. So we want the output of read to actually be the same thing. Cool. Yeah, read block actually has this as an output. We're going to steal the same thing again. We're going to say records. Cool. Here's our records. We're actually going to return records. Now it's not going to scream at us. Amazing. So look up my indexes. Here we're going to say combine all indexes via leapfrog to do. Cool. That gives us a good sort of indicator for what we should be doing next. Now, we are actually going to bring our filters back in. So ironically, it's pretty much going to be the same block. We want our list of filters back in here. We're going to bring the Boolean add record, record is record, blah, blah, blah. Nice. And then we return records. And so when we go to SQL test, we're going to put an empty array list. I think I'll just be able to do that. Yeah, nice. Then we're going to say our response is this. Then we're going to utils.pp response. We're going to rename this from read block to read with indexes. Read with indexes. We're going to go here. We're going to rename this to read with indexes. So this is just full table scan essentially. Yeah, I guess they'll be the same, but then they'll take a different path depending on my day's good, by the way. Hope yours is as well. I'm very focused today, as you can see. Combine all indexes, leapfrog, etc., etc., etc. We do this with fucking read with indexes. Boom. And we read all the apply events. And so it's kind of cool here. It's kind of cool. Is if we go to app Java, blah, 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 blah. I think we can actually put, don't I have, yeah, filter new match. I think I can put a fake ass filter here. We're going to say where ID is less than 4, read with indexes. I'm going to put this here. Where did I paste? No, it's unhappy. We're going to take this, boom. Why can I not paste? The hell? What happened? Can I copy this and paste this here? Interesting, copy pasting broke. Okay, we're gonna say list of filters called filter list equals new array list, boom. We close this, and then we're gonna say filter list dot add new GT. I think here we say column name, and we're going to say ID, and it's greater than 2. And here we're actually going to pass in filter list, because to simulate a fake filter. So now we should only get one row. Boom. We only get apply. That's wild. Okay. And lastly, before I bounce, we go here, we say read with indexes, blah, 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 blah. And I should have, so for each of my filters, this filter dot invoke, kind of curious. I'm gonna say for each filter as filter, we're gonna utils dot pp filter. I'm kind of curious. Let's do that again. Let's do this again. Hour and a half, pretty productive. That's good. So we see that was a bit dumb. Filter. Let's go see what our filter looks like. Filter. Where's our GT? GT is going to be its public column name. We're going to say filter dot get column name. And I guess, what are you upset about? Filter dot column name. I guess I don't need to do the get. I guess if we do that, it's going to be there, but it's cool because all of them have it. And we're going to say column name equals. We're going to see that the column name equals null. Not cool, my friend. Not cool. Not fucking cool, man. Because we have column name, right? Filter, object, column name. And when we go to GT, why did this not explode? Why was this not like super pissed at us? Like, hey, what are you doing? Oh my god. If that's my filter, I'm running out of steam. I guess it's because somehow it's not overriding. What if I say at override? I have a class that extends filter, not index manager, not app.java. You know what my assumption is? If I do this and say hello, this is going to say that the column name is hello. Let's try this. Yeah. I have a class that extends filter. I have an abstract base class called filter that has a value for column name. Did that paste? Then, sorry. Then, lens filter. Where's my greater then? Where the we're gonna do that dependency injects a different column name. However, when I loop over filters, I get the base value, not the value that was injected for the specific implementation. How to actually get the value of the filter itself, not the abstract parent. I'm surprised that that's how Java works. That's strange. Java handling field hiding. When you declare a subclass, it hides the field from the same name in the superclass filter. However, hiding does not work for method overriding. Shitty. Alright, let's make a getter. Let's make a fucking getter, baby. Let's go. Let's go for get column name and check this shit out. In SQL.java, we're going to say filters.get column name. Look at that. Sure. Where is it? Oh my god, so dumb. But, public? Okay, no more errors. Let's try. Let's go. Show me ID. Yeah, buddy. Alright, so I have to use getters and stuff. I'm gonna have errors on other stuff because yeah, the rest of them should be fucking screaming. EQ boom, boom, GT, in, whoa, 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 GT, LT, they all need this, otherwise they're all going to be very upset with me. They're all going to be very upset with me if we don't do this. Cool. Ah, I need to sit up straight. We're going to close, 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 close. Cool. SQL-test.java. Nice. Noise. Index test, we're done with this. Read with indexes. So we have our column name. Now, something we're going to very quickly do is we're going to go to index, and we're going to actually delete this. Look at that. Boom. Dead. We're also going to delete the test DB. And in the index manager, we're going to have to fix a bunch of shit. So we're going to have, actually, the index manager is going to require the string table name and the index name, like this. So now we're actually going to file writer. We're going to go plus, sorry, we're going to do another plus here. We're going to do another plus. So here we're going to say table name plus, I don't think this is going to create, will this create the directory by default if it is not present? If not, please show me how to ensure the directory gets created dynamically. Because I have a feeling it's not going to be very happy. We're going to copy this. We're going to say file path. And we're going to do string file path equals boom. And the reason we want to do that is because we're going to be using it twice. It's just going to be easier to modify shit. In Java, does not automatically create parent directories. Nice. We have this whole fucking situation here. Where's my gis on? Gray. Alright, we're gonna, let's steal a lot of this. We're gonna put this here. So directory path, and do we eventually use a file path? Yeah. We're gonna say, okay, fine. We're gonna say string directory path, which is gonna be that. Then we're gonna immediately do this. I guess somehow it's upset. Sure. If the directory doesn't exist, make the directory. Cool. Then immediately we're going to do the file path, which is just going to be this. Nice. Then we're going to do our JSON. Nice. So writer, file writer stays the same, file path, and then all of that stays the same. And the read should be fine. So let's try something right now. I think if we go to our insert, broke everything. I broke everything. Oh, good, 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 good. This is a good mistake. test2.db, we're going to delete this shit. That's good. Where do we use it? So in SQL test, in index manager, we're going to say index manager. We never use it here, which is strange, but I guess we use it with here. We're going to say index manager. That's one. And we're going to put apply. No, we're going to put event, because we're putting the index on event. Read index name, so we're going to need string table name and then index name. And then read requires 2 arguments now, right? Yeah, okay, cool. So it requires, where was I? Index manager. Read requires the table name and this. This requires the table name and this. Commit requires the table name and index. So everything's chill here. I do see red. We're gonna fix this first. Okay, why are you red? We don't have a plus here. Nice. Why are you red? It's up here. What's wrong up here? Update index. We need our table name. And we need this to say event. Nice. So let's try this again. Holy shit, it succeeded. We go to index. Now we have test2, and under test2 we have event.json because we have an index on event. Now, when we go to our read test, read with indexes. Nice. So let's go to read with indexes. And what we're going to do here, here's our filters. And I guess we're going to sort of ask. I guess what we should do is in our schema, we should automatically just say that, hey, this thing has an index, but we're going to cheat a little bit because I'm getting tired. We're going to say does I'm getting burning out. So we're going to do something along the lines of, so we're going to say string, and then we'll say string filter on column. Then we have to ask a question here. We have to say, like, we're going to put this into a method. For now, we're going to say private void does column have index. It's a bit dumb, and I guess we'll say booleano, and we're gonna just check if the directory and the file exists. We're gonna do something check if file exists via Java. So we're gonna do, like, does the file exist? But we're gonna put a comment here. For now, I'm asking if the index exists, but I should have it in my schema whether or not this column has an index. Oh, let's go directory blah 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 blah. File, if file exists, we're gonna do that. We're gonna pass in a string table name. We're gonna pass in a string index name. We're just gonna say new file is index slash plus table name plus slash boom boom boom, and we're going to return false, and here we return true. And so let's try something now. We're gonna say utils.pp does column blah 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 filter on column match. Why? Oh no, yeah, dumb. Where's my table name? Nice. Column plus filter on column plus has index equals plus goes here. So now we're gonna bring in our filters again, and in my filter, and I guess it should only be a GT, but we're gonna say EQ event désolé. We're gonna say apply. I don't know why I can't do quotes anymore. Cool. So now we should have two filters. We don't need this. We're gonna run this. Meow. Column ID has an index. Column event. Column. It's ironic because, wait, I think I did the has index backwards. If file exists, return true, otherwise return false. Nice. So if it does exist, we don't want an error, we just want to run this shit. Cool. So if it does exist, check this out. We're going to say if we're going to say if this is true, we're going to say indexes is indexes. It's a little ugly. Well, we don't need to do this. We're going to say new array list. Nice. Now, if this is true, we're going to put the table name. We're going to put the filter on column. Again, this is all very ugly, but it's okay. Then we're going to search the tree for the results. We're going to copy this. We're going to say column column indexes. I'm going to move this here. And then we're going to say we're going to say something like maybe we want like a set. we want this, and then within a for loop, I have a method that returns an array list integer. I have I want to loop, I want to show me how in Java to add those values to this running list, ensuring only unique records. Or is that dumb? I guess if I have two filters, should I be putting all of them? So like, first one, event, is going to be like 1 and 4, but the other one's going to be like, oh, you're present in 2. We're going to be, yeah. But this is dumb. Leapfrog here somehow. Start leapfrog. Because otherwise, that doesn't make sense. They need to be mutual. They need to appear in both lists for them to be true. Indices dot add all. Nice, nice. We're gonna say column indices. Yeah, baby. All right, sick. Let's try this now. We're gonna utils dot pp, and we're gonna say my indexes are with a little plus. With a little plus. One and 4. This returns only that. That is wild. Alright, that's good enough. There's a lot to do still. We need to add leapfrogging. We need to think of better block sizes. I'm going to go for food. I'm going to think about this more. But this is good. This is good. Thank you for watching. Enjoy whatever it is you're doing. And if you're watching the recording, hey, and bye.